Is the West Pacific becoming the focus? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 5th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Coach Nate, Our Predicament, Tim Caston, Clay Goose, B. Nadine, and Evolution Moto. All these are longtime contributors. Like every week they're donating. I can't tell you how much I appreciate it. And again, thank you very much. And with that, let's get to work. We'll start by looking at significant wave heights for the entire planet. We'll start in the North Pacific. A little bit of disturbed weather up here in the Bering Sea, but not doing anything to produce swell relative to Hawaii or California, our main forecast areas. But there are two tropical systems here, Octave and Priscilla. We'll get into a little bit of the details with these, but the short of it is not a whole lot is expected from them. There is another system over here in the West Pacific, Halong with winds 55 knots. That holds potentially an entirely different story. Down in the South Pacific, we have a gale with 26-foot seas. It looks like something like that says. Oh, actually here, 28.5. These are the highest seas over the entire domain. Seems hard to believe. So the highest seas over the entire planet right now are this little tiny gale in the South Pacific Ocean, 28.5 foot seas, winds in that area, 43.8 knots, at least according to the model. Heading to the North Atlantic, there is a gale. Again, it looks like it has about 26 or 27 foot seas. Notice this gale here tucked up right in there, like in the most bizarre place it could possibly be. But I actually have I'll call her a Facebook friend that is on a cruise out there right now, and the report is it's pretty ugly, pretty bouncy, 24, 25 foot seas it looks like, and that's over, that's a small area, so the wind must be blowing really hard. And then finally over to the Indian Ocean, a calmer pattern with 24-foot seas right in the South Indian Ocean, maybe a little bit of something here south of Tasmania. But in all, looking at everything, it almost looks like the tropics are more the focus than anything, at least for the moment. But first, let's take a look at current conditions. We're going to look at the buoys. Starting up in the Pacific Northwest, the Grays Harbor buoy, Washington, 036. It's really right there on the border between Oregon and Washington. We're looking at all the energy that's hitting that buoy all the way up from 33.3 second period. That'd be very energetic swell, which there is none, 0.0 feet, the whole way down to 5 second period, basically wind chop. It looks like about a half a foot. Most energy in the 7 to 8 second range, and little dribs of southern hemi energy sort of in the mix. Let's see what the algorithm tells us. Primary swell, 4.5 feet at 7.9 seconds from 303 degrees, theoretically making surf at 3.6 feet. And that's, I don't know, might even be a little bit bigger than that. It looked just a little bit ago. Then some secondary swell, 1.3 feet at 11.3 seconds, again from the west, 274 degrees. Surf only 1.4 feet. So looks like the wind swell is dominant for the moment. Down to Northern California, the Point Reyes buoy, number 029. So now there is a little bit of energy here in the upper period ranges. This is leading edge of a very tiny southern hemi. I would call it even more maybe like a Tasman Sea background swell trying to come in. I have zero expectations for it. Mainly wind swell appears to be the focus. Primary swell, 5 feet, 6.8 seconds from 316 degrees, making surf 3.4 feet, and that's about what it is, waist high, something like that. Secondary swell, 1.7 feet, 11.1 seconds, also from 280 degrees, and that's just buried underneath. down to Southern California. Oh, there we go. The Point Loma South Buoy, number 191. They're off of San Diego. Now you see little bits of the Southern Hemi swell showing up better down there, protected from wind swell, and a little bit further south and a little bit more exposed, and a little, or actually a lot bit less wind swell. See how this all pulls together. Oh, nope, still. Wind swell is the primary swell, 2.3 feet at 8.5 seconds from 274 degrees, making surf a whopping 2 feet, with secondary swell 1 foot at 16.5 seconds from 215 degrees, making surf at 1.7 feet. And just a quick check down south, it all looks pretty quiet. And then over to the north shore of Oahu, Waimea Bay, buoy number 106. This was quite a surprise today. We knew there was swell coming. Didn't think it'd be that big, but you can see some pretty big spikes here. I mean, just right in a single individual period band, 4.5 feet, 4.8 feet at 11 seconds. And the actual swell is sort of an amalgam of all the energy in this generalized area. Primary swell, 7.9 feet at 12.3 seconds from 332 degrees, making surf 9.7 feet. I think that maybe is a little bit of a reach, but there is definitely swell. I mean, the thought was it'd be more like 5 to 5.5 foot Hawaiian, so models definitely got that wrong. On every count. I mean, the storm looked incredibly meager. Can't believe it's as big as it is. And then secondary swell, this is just local wind swell, 3.7 feet, 8.8 seconds from 286 degrees, adding in some 3-foot lump into the mix. All right, let's take a look and see what's been going on for the past week. This is a Hindcast, of course. You have to have wind blowing on the ocean surface. That generates a swell, and then that swell takes a while to reach your break wherever you happen to be located. So it's good to sort of look back, one, to see what either swell might be coming or see where swells that are currently hitting, where they came from, and to sort of get a general feel for, well, what's the pattern right now? And then we compare that to the forecast. Well, what will the pattern become? All right, so tropical system, Neo-Guri, with winds 84 knots according to the model, seas 48 feet. This was on Sunday, a week ago. Recurving, it was like noodling around here and then finally recurved. Well, we'll just put it in motion, you can see. And it died about the time it hit the date line. Swell from it has already come and gone in California. It was very small, buried in local wind swell. This system here off the coast on like Tuesday, Wednesday, created larger local swell, but there was a window on one day there, but it was kind of a mess. There was also, what was this? NARDA? Yes, NARDA. South of Southern California, back, we'll go the whole way back here on Sunday. And then there was NARDA. That also produced some swell lifting north into Southern California last week. Beyond that, we're into Saturday and Sunday, and not a whole lot is happening. This is the beginning here, I believe, of a new system, Halong. To the southern hemi, a week ago, Sunday the 28th of September, a little bit of a gale here developed, kind of hit and miss and gone. I don't know that any real meaningful swell is going to come from that. And then we put this into motion. Now this little system and a little bit of other stuff here, maybe this just not great, but maybe a little bit of swell will result from that. And here you go. You see it also pushing north. That was Saturday into Sunday. Again, very small fetch areas. Seas were only like, 28, 29 feet. So nothing huge. It was like throwing a pebble into a pond really hard. It's just doesn't have enough mass to generate a whole lot of swell. So other than that, southern hemi pretty quiet. Over to the Atlantic a week ago, Gabrielle, and then over here, Imelda will pop up. There is still, it seems like, swell from those two, and you can see they sort of almost tried. There was rumors that they were going to orbit around each other. Never happened. They basically just sort of ran off to the east. Now, notice Imelda here. This was on like Friday. Actually stalled for a little bit out here. Seas rebuilt to 34, 35 feet, and then it took off again off to the north, and there we are at current time, or off to the northeast. Residual wind swell from high pressure building off the northeast coast is currently producing wind swell pushing into most of the southeast coast from Cape Hatteras down to Fort Pierce or something like that. To the South Atlantic, last week on Sunday, not a whole lot was going on. We'll put this into motion, see if anything actually did materialize. Local gale trying to set up, generate some seas. There's a tiny area of 20-foot seas. This is on Wednesday into Thursday, and that was about it. Another system trying to get going with like 18, 19-foot seas on Saturday. And, whoops, that was it. That's about, so basically, it kind of looks like, by looking at the South Pacific, looking at the South Atlantic, and then we'll go take a look at the Indian Ocean here, but it looks like the switch is really happening in earnest now, with the South Ocean starting to go to sleep and the North Ocean starting to wake up. And then here we go. Indian Ocean, a little bit of a gale, 34, 5-foot seas occurred. That's long gone. We're into Tuesday, Wednesday, Thursday of last week. Let's see if anything else meaningful shows up here. We're into Saturday and current time. Definitely, you can see just even from last week, the pattern has significantly backed off in the southern oceans now. So now we'll do a deep dive into the North Pacific Ocean. This is our main focus here. We're going to start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push into the jet to the south. Right there, that sort of qualifies. What that helps to do is create a counterclockwise flow, a eddy aloft. That also can manifest itself down at the ocean surface. And of course, that is the hallmark of low pressure. Low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface, imparting energy to it, creating raw seas. As the seas radiate away from the fetch area, the lesser period elements, because they have less energy, decay more or decay away completely, exposing longer period swell, and swell when it hits your beach definitely creates surf. All right, so the jet stream is the foundation for the whole thing. We have a bit of a trough here in the northwestern Gulf, but the jet's kind of split here just west of the dateline. We have the opposite of a trough here off the U.S. west coast, a ridge, the jet pushing to the north. That supports high pressure aloft, though there is residual cutoff low pressure energy here in the jet. This is the remnants of what created the swell that's currently hitting the Hawaiian Islands. All right, so let's put this in motion, see what we have coming. The trough in the Gulf pushes into the northern Gulf, way too far north, doesn't get really any traction. We get a developing ridge as we get into Tuesday, the 7th of October, so this would be high pressure out in here. But we have a building trough right here south of Kamchatka on about the 160 east latitude line. That would help support low pressure development. Also know a little bit of a cutoff low, trying to organize off of Vancouver Island as we get into Wednesday, October 8th. But really pinched off. Another trough, the first trough fades, another trough tries to organize, pushing off Kamchatka. But again, it's all up here at like 50 north, something like that. So that doesn't do a whole lot to support gale formation. Then we continue on full-on cutoff low off of Oregon and the Pacific Northwest as we get into Friday. You see this here, the pattern, sort of like the title of the video. It was the West Pacific becoming the main area of activity. It sure seems that way. Jet strong here, the jet weak and split in the east. We had talked about this for probably a month or more now. When we get into the MJO section and the long-term forecast, this is pretty much the pattern that we were forecasting. 150 east right here was somewhere between here and here was the cutoff between the low pressure bias here, high pressure bias here. That would support the jet stream raging to a point, hopefully as we get deeper into winter, further downstream, but definitely would still support a general pattern of high pressure over the U.S. West Coast. Now, that high pressure, low pressure bias was actually down here on the equator, or is actually down here. So low pressure there, high pressure over in here, but that affects everything north and south of it. All right, so we're into Friday. We'll just roll this out. The cutoff low moves into the Pacific Northwest on Saturday. Jet remaining strong and trying to dig out yet another trough as we get into Sunday, a week from now. Notice winds up to 190 knots in one little pocket, but in general, a fair amount of energy in the jet. It just needs to sink a little bit further south. Right down to the surface. Surface level pressure, surface level winds. No big surprise. Massive high pressure, 1028 millibars, double lobed, filling the bulk of the North Pacific. This was the concern with La Nina, and it appears to be manifesting itself, at least for the moment. It's still pretty early in the season. And then we have our systems. Priscilla here with 65 knot winds. Octave here with 70 knot winds. And Halong here with 55 knot winds. We'll put this into motion, see if we can get some insight as to what's going on here. Priscilla lifting off to the north. Octave actually retrogrades back to the west, so they are kind of orbiting each other to some degree. And Halong heading off to the north. I'm looking for any other signs of fetch, not really seeing it. Now watch Halong, notice low pressure up here, and notice Priscilla heading off to the west. It was supposed to forecast to be heading almost due north. That track has changed now. So we got, as we're into Thursday, I mean, Thursday's the beginning of it. It's 9th of October, 45, almost 50 knot winds pushing off the North Kurils. Halong here looking pretty strong. I'll bring up a chart on that in a minute, and then you see it recurve hard off. Priscilla finally stalling on Friday, and then forecast moving off to the north with another system potentially behind that. Halong racing off to the northeast, sort of, oh, now this is new. I hadn't seen this. Building dramatically in the northern Gulf as we get into, well, early Monday. That's a week out. I don't believe it. And another system behind that. But again, West Pacific seems to be the focus. We'll see how this all plays out. Here's the track for forecast track and strength for Halong. Winds building 100 knots, 120 knots. What's that? Nearly like 130, 135 miles an hour. 125 off of Kyoto, Japan. Recurving off to the east as we get into the 9th and then the 10th. Accelerating off to the northeast. I mean, this is great. Again, this speaks to the low pressure bias here. Likely westerly anomalies in this area. If we were in full La Nina mode, there'd be so much high pressure and easterly anomalies, this would never happen. So my guess is this is attributable to some form of low pressure in the Western Pacific, as the models have been forecasting for a month or more now. All right, so the forecast for significant wave heights over the North Pacific Ocean for the next week. Halong here? Sorry, that was Octave. Priscilla down here. We'll put this into motion. You see Octave retrograding, Priscilla building while heading off the east, Halong doing its track. Where any other activity here, not so much, at least for the moment. Now here is Priscilla. Building looking pretty solid, but pushing off to the west. Sideband energy, if it's not moving too fast to the west, sideband energy at some point, once it moves into the swell window, I think it's somewhere around 115 west, that would open up the swell window for San Diego and exposed breaks in Southern California. Put this into motion. We got two of them. Here's Halong doing its thing with 40-foot seas, supposedly. Another low-pressure system building with 31, 2, 3, maybe 34-foot seas. This is into Thursday. And then fading from there. Halong off to the races. Actually, let's roll this back. There we go. 48-foot seas, very much like the previous system was at Neoguri. Long ways away, but aimed more due to the west, so maybe, or to the east, so maybe some hope there. there's a lot happening here. I don't know how much any of it will support gale development. And then as we get to the very end of the model, 2 systems forecast here, that definitely would support swell. That definitely would support swell into Hawaii and more so into California, the Great Circle path coming up, something like that. These, if most of their energy is aimed off to the east, Hawaii's down here at least 45 degrees off the path, so sideband energy at best. To the South Pacific Ocean, our gale still in the swell window, producing 28-foot seas. That's as of Sunday, but forecasts to pretty much quickly fade off. Beyond that, looking for anything, I'll say 28-foot seas or better, aimed off to the northeast. Got 28-foot seas, but they're falling southeast. Probably no energy or nothing meaningful lifting off to the northeast. By the time it does, you see right there, it's all but gone. Just keep on pushing. There's 180 hours out. You go, why don't you go out further to 240 hours? Because the model falls apart. After 5 days, really, this is all just a wild guess. So, somewhere around the 150 hour mark. Okay, yeah, that sounds good. I'll keep my eyes on that. When you get into 180 hours, it's fantasy land, and anything beyond that, the odds of anything forming on the charts that far out is at best just a wild guess. To the North Atlantic, remnants of, I don't remember what, Gabriel, I think it was, off and gone. Was that right? Yeah, it was Gabriel. And then we're into Tuesday, Wednesday. So the next tropical system sets up approaching the windward, leeward islands, lifting north just barely of the Virgin Islands. This is much closer than previous runs of the model. Now we're out onto Friday, so who knows. And then tracking pretty much north from there, seas 37 feet. Where are we? 144 hours. And then heading due north, so no landfall expected from this. But I did go look at the models going out way further. This system theoretically lifts north, kind of stalls, maybe redevelops, gets wrapped around, falls south. And in the fall months in the southeast coast of the U.S., this happens. You get these kind of trapped lows because you're getting cold fronts starting to push off the northeast coast. High pressure blocks the exit path of low pressure to the south. They just stall, forms a pressure gradient, and that generates surf. A lot of times pretty stormy, and that's what's been going on for Florida now for, I don't know, a week or something like that. But it is surf, and you take everything you can get. To the South Atlantic, we'll put this into motion. Little bit of a fetch. You saw that there, just barely brushing by South Africa on Monday, the 6th of October, with like 22-foot seas. Another low develops, but kind of fades before it even gets anywhere close to South Africa. See if there's any other hope here on the charts. We're out. There we go, 180 hours. So definitely a quieting pattern setting up for the South Atlantic. And then to the Indian Ocean. Let's see what happens. I kind of have my guesses of how this will play out. Well, you get 28-foot seas targeting, I'll say Perth on east from there, and lifting northeast. So that definitely has swell potential for southern Australia into Tasmania. Not so much for Bali in that area, though. Another gale tries to develop, but it's just pretty weak, 22-foot seas. And that was the end of it. So again, the calming pattern in the South Oceans seems apparent. The North Oceans trying to wake up. Seems like the Pacific, if anything, is doing better than the North Atlantic. All right, local wind forecast for California here, Hawaii here. This is the GFS model. Southern California here, there's Point Conception. Northern California, Monterey Bay and Santa Cruz, like right in there. This is San Francisco here. Then north of there, Northern California. We see high pressure, 1030 millibars. Ridging into the coast, producing a pressure gradient with lower pressure inland. The tightening of the isobars right in here. I mean, this area, the Cape Mendocino area, is just a wind machine, which is great for generating wind swell down into central California for the most part. Northwest winds 20 and 25 knots. Hawaii under light trades in the 10 to 15 knot range. And then we have, which one is that? I think that's Octave out there, retrograding. Maybe some hope for Southern California from that. We get into Monday. Pressure gradient starts lightening up a weak wind regime for California. Trades light, like northeast, 5-10 knots for the Hawaiian Islands. Tuesday, same deal, pretty much light wind regime. Look at high pressure here, bulletproof 1038 millibar moving into the Gulf of Alaska. That would certainly shut down any swell generation potential. Light wind regime continues for California, same deal for the Hawaiian Islands, so turning a bit south-southeast, 10 knots. Thursday, here comes Priscilla, looking much more robust. Potentially some southern swell generation potential. Light wind regime for California this Thursday, the 9th of October. Light winds out of the southeast for the Hawaiian Islands. Friday, same sort of deal. The high pressure just lingers, can't get into the coast for whatever reason. I'll take that any day of the week. Saturday, here we go. Then it starts pushing into the coast. Light winds for the Hawaiian Islands, but you can just sort of sense a building wind pattern as we get into Sunday. Here you go for Northern California and Central California. 20-knot northwest winds. Maybe you'll take a little hit out of the water temperatures, but hopefully not too bad. And, of course, our gale building here in the northwestern Gulf and a light wind regime for the Hawaiian Islands. Precipitation forecast for California right here. Again, Central California, Northern California. With high pressure in control, one would not expect a whole lot of precip. Now, I'll just stall here for a second. There was some snow over from the last systems. I think there's still snow in the on the upper mountain at Mammoth up at 11,000 feet. You know, like maybe even, I think they got maybe up to a foot at one point. Now, temperatures are quite warm, and it's all going to melt off. The point I'm saying, there was even a dusting at Squaw Valley, too. Much lower, though. Squaw's peak elevation is like 8,900 feet. It snowed and then turned around and melted within like a couple of hours at best. The point being here, I'm looking for any precip moving into California to potentially try to refresh that snowpack. So we get into Saturday. Now here we come, a little bit of a cutoff, that cutoff low pushing into Northern California on Saturday. Doesn't even make it south, much less, so Mammoth is like down here. Palisades, Tahoe, not Squaw Valley, is in this area, so you get the general idea. And no obvious monsoon flow pushing up into Southern California. Hikers, temperature forecast. This is, really late in the season. I don't think anyone's hiking on the PCT right now, the Pacific Crest Trail, but this is a good proxy for what's going on maybe in ski resorts across California. This is the intersection of the Pacific Crest Trail and Tioga Pass Road going over the high country at Tuolumne Meadows there in Yosemite. This is the elevation at that intersection of the trail and the road, 8,700 feet. Actually, the height of Tioga Pass Road, I think it goes up to like almost 9,800 feet right at the summit. Anyway, temperatures for Sunday in the 40-degree range. 40, right at about 40. Tuesday, 40 to 45 degrees. Maybe even 50 degrees as we get into Saturday a week from now, and then cold air coming in. But you see, here's the freeze line, the red line. None of that getting down to even the 9,000-foot mark, which would be the top of most of Lake Tahoe resorts. So still a pretty warm pattern and no rain forecast for the next week. All right, so let's play a guessing game and see if you can pre-guess what the surf is going to be like based on all the model data we just looked at for select spots in California and Hawaii. There's actual surf heights. No big surprise here. 2.5 feet, 2.5 feet, maybe a little bit of 4-foot wind swell in there. And supposedly something in the 5 to 6 foot range as we get into next weekend, that all probably being wind swell. Let's look at actual swell heights and periods. 3 feet at 8 seconds, 2.5 feet at 6 seconds. 1.8 at 14 seconds. That's probably coming from across the date line. Another little bit of 3 to 4 feet at 10 seconds. Little bit of background southern hemi swell in the mix. So in general, pretty calm pattern for the Pacific Northwest. Down to Ocean Beach, San Francisco area. Okay, here we are Sunday, surf heights in the 3.5 foot range, which is exactly. Down to San Diego. Not a whole lot different here. Surf heights 1.5 feet, maybe building to 3 feet as we get into the latter part of the work week and into next weekend. Swell heights 1 feet at 13 seconds from the south. Background energy building to 2.5 feet, 11 to 12 seconds. My guess is that's probably hurricane swell there, and then wind swell takes over. So pretty calm regime for Southern California. The North Shore of Oahu. Okay, as we get into Sunday, you see the forecasted surf heights were 5.9 feet. And what did we get on the buoy? It was like pushing 9 feet, something like that. So you could see how badly the models misjudged the storm that produced that swell. Anyway, surf heights, as expected, dropping from there to almost nothing as we get on Thursday, and then hanging in about the 2.5 foot range. Nothing really expected there. Let's see, 5 feet at 11 seconds, down to 3 feet at 8 seconds, 3 feet at 9 seconds. So nothing remarkable going on. We head over to Jefferies Bay, South Africa. Now it says surf heights like nothing, but you see these, when you get these big drops, that's some major wind swell event. Winds offshore there at 30 knots, 25 knots. So there's something more going on. And then all of a sudden it jumps to 15 feet, drops down, and then back up to the 11 to 12 foot range as we get into Sunday and Monday. Let's look at swell heights here. 8.7 feet at 9 seconds. What do we have here? 13 feet at 11 seconds. Yeah, this is all just pure wind swell. Yes, it could be rideable, but it's not like the groomed long line perfection wrapping around the point that one would expect. Maybe better odds of that here as we get into Saturday, but I noticed here that even the winds south-southwest, that's probably not ideal. And then finally, Bali, surf heights in the 9 foot, 8 foot range. That's previous swell from, generated last week sometime. Heading down to the 3 foot range and then only coming up to the 5 to 6 foot range after that. Let's look at swell heights. 5.9 at 14, another little, same sort of thing, 5.5 at 13, that whole swell fades out, and then you get another 4.3 at 13, 14 second range. So the swell period levels definitely dropping off here as we get deeper into the fall season. All right, let's go take a look long-term at the two major weather oscillations that affect the potential for storm and swell development. That is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We'll start with the Madden-Julian Oscillation. There are two phases, the active phase and inactive phase. These two phases rotate around the planet from west to east on the equator. One on one side of the planet, the other on the other side of the planet, rotating around like that. The active phase is our friend. It is a low pressure system. It takes warm, moist air on the equator, lifts it up into the upper levels of the atmosphere. That gets tapped by the jet stream. That energy, or that warm, moist air energizes the jet stream, making it stronger, consolidating it, making it more capable of digging out troughs that then support low pressure and storm development, and also help push the jet stream over in the West Pacific stronger into the East Pacific, sometimes producing snow and rain into California if the jet is strong enough. The inactive phase of the MJO, exact opposite. It acts like a cutoff. It's a high pressure system. It's falling air that cuts off the flow of warm, moist air up into the jet stream. The jet stream gets weak, it splits, and it doesn't support trough and gale development. So we can, the inactive phase of the MJO, because it's a high pressure system and because trade winds are generated by high pressure. The two of them, if they sync up, trade winds get stronger than normal. When the active phase of the MJO is over the Pacific or your area, because it is a low pressure system, it sort of chops the legs out of high pressure and therefore makes trade winds weaker. So you can sort of tease out by looking at the trade wind state across the Pacific, and that's what this is, whether the active or inactive phase is over the Pacific and where exactly it is. So this is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but you can derive 5-day average winds from that. The arrows here. The longer the arrow, the stronger the winds. So in the East Pacific here, yeah, this is the East Pacific. This is the West Pacific. This is the equator. The international date line is right there. Winds pretty strong out of the east and the East Pacific, pretty strong over the Central Pacific, and solid strong in the West Pacific. So just eyeballing this, it looks like inactive phase of the MJO. But it is not the actual wind speeds that matter. It is the anomalies, the difference from normal for this time of year. And so, yes, trades blow naturally strong certain times of the year, not so much other times. Looking at the arrows here, they're very weak and just really going nowhere. So I'd call this a normal wind pattern in the East Pacific. Same thing in the Central Pacific, but here you go. Easterly anomalies, enhanced trades, inactive phase of the MJO, likely here. Oh, that's New Guinea, by the way, down there. So, yeah, not a great pattern for supporting gale development. Here's the forecast for the next 2 weeks and what has been happening over the past month. Past month is on the top. The forecast down here, this is the GFS model, 850 millibars zonal wind anomalies. So that is winds up about 4,700 feet off the ocean surface, but it gives you a pretty good idea what's going on at the ocean surface. Oh, and let's get ourselves organized here. 180. This is for the whole planet. So this is the date line. The far West Pacific starts about 125 east, so right here. Okay, the yellows and reds, westerly anomalies associated roughly with the active phase of the MJO. Blues, easterly anomalies, stronger than normal trades, inactive phase of the MJO. So here we are today. Our main area of interest is the West Pacific, because once the jet pushes over there and gets energized, typically, as you get into winter, it gives it enough momentum to push it the whole way across the Pacific. California at 120 west here. All right, so easterly anomalies on the date line, a little bit of westerly anomalies today, just barely getting their toe in the door to the West Pacific, retrograding over the next couple days, then rebuilding on the 10th of October, making it about halfway across the Kelvin wave generation area, or halfway to the date line, then retrograding from there. So in all, no strong indications of the active phase of the MJO, and this has really been our problem now for months and months now. We talked about it in last week's video. Just the MJO is dead asleep for whatever reason. Outgoing long-wave radiation forecast. That's cloud cover, basically, for the planet for the next 2 weeks. The active phase of the MJO, being a low-pressure system, takes warm, moist air, pushes it aloft. Eventually, that warm, moist air is going to hit cool air aloft and condense into clouds, and that's effectively what this chart shows. Blue shows more clouds than normal. Red, less clouds than normal. This would be like inactive phase of the MJO. This would be active. Today, weak inactive phase. Oh, yeah. Let's go South America, Central America, Hawaii, New Guinea, Australia, EQ, the equator. Right there, 180. That's the international date line. It is this area right here on the equator in the West Pacific that is where we're really looking for an active phase of the MJO to help feed in energy to the jet stream. But today, nothing. In fact, trade's a little bit stronger than normal. Dead neutral 5 days from now, dead neutral 10 days from now, and weakly inactive 2 weeks from now. Pretty much a dead neutral MJO. That's per the statistic model. Now the dynamic model, which was sort of what we were looking at in the previous model, shows building easterly anomalies 2 weeks from now, inactive phase of the MJO in control. So no hope here. This is the exact opposite of what one would want to support gale and storm development. Let's keep digging. Phase diagrams for the same two models. How do you read this chart? Well, this maps where the active phase of the MJO is and how strong it is. The MJO moves from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States. Remember, this is on the equator. Over the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is, so somewhere in the Indian Ocean. And if the dot is anywhere near or inside this circle, it's so weak as to be insignificant. The ideal situation is you want the that heavy dot to be sitting out here on the outer edge of the chart in the West Pacific. That would be like just pouring gas on the jet stream, feeding storm development, be it in the summer or the winter in the North or South Pacific. Clearly, that is not happening. And the forecast per the different runs here of the statistic model have the MJO basically going nowhere. The dynamic model, the GFS model here, same sort of deal. Active phase going to retrograding to Africa, noodling around in the West Indian Ocean, and almost back where it started 2 weeks from now. So no hope indicated on these charts. And then the CFS model. This goes out 1 month. Past performance down here, the forecast here. Again, reds are westerly anomalies, typically associated with the active phase of the MJO. The blues, stronger than normal trades, easterly anomalies associated with the inactive phase of the MJO. Now this chart actually indicates the MJO, a solid black contour. But notice whatever little bits of MJO activity there have been, they've just been like these little tiny fragments. A real active MJO, you'd see a black line, a circle going the whole way across the chart. This is time. So starting in the West Pacific or in the Indian Ocean, moving to the West Pacific, over the date line, south of California, and the whole way around the planet. Don't see any hope there, but we do see an inactive phase of the MJO, and it's like almost semi-connected. I mean, it's not we want the active phase. This is the inactive, but at least it's an indication maybe that the MJO is going to try to wake up slightly. It typically does as you get into fall. All right, so what do we got here? Easterly anomalies over the Kelvin wave generation area, not doing anything to support gale development. We have an equatorial Rossby wave forecast to push across the Pacific a week from now, generating westerly anomalies. Take it any way you can get it, but it's only like 4 days worth, and then boom, here come your easterly anomalies, inactive phase and control, at least into November. Let's go out 3 months now. Here's the CFS model going out 3 months. Past performance down here, the forecast up here. The same big T's. Oh, and let's start. Dateline runs right up the middle. Far West Pacific starts at 125 east, so roughly right around there. Here's the same big T's this model's been saying. Westerly anomalies building. They were supposed to start building, I don't know, 6 weeks ago or something like that. Still hasn't happened. Supposedly in 3 days, yes, westerly anomalies build, but then you pretty much see this is probably the inactive phase of the MJO. But then as you get into November, magically the westerly anomalies start. Okay, well, that sounds like a little bit of snake oil. Let's go take a look at the MJO. Let's overlay that on here. Okay, so here's been our MJO pattern with 1, maybe 2 contours at best. We get into let's say just before Halloween sort of thing, inactive phase of the MJO, just like what we saw in the other chart, building easterly anomalies. Then you get into the first week of November, a 3-contour active phase of the MJO sets up, and westerly anomalies supposedly come in and hold, if not, notice this, building the whole, almost to a point south of California. That would be basically filling the entire Pacific. You go, yeah, whatever. I don't believe that. But here is the thing. And this is part of what the title of the video is about, the low pass filter here. All right, so back, the solid contour is the low pressure bias. The dotted contour, the high pressure bias. And all of a sudden, well, you look at this, and if you go the leading edge of the low pressure bias, notice it moved from the far West Pacific to about midway across the Pacific in sometime in early August. Then you go to here, and this is something new on the model just this week since the last video. When you get to right about there, the end of October, let's say Halloween, and all of a sudden you see the easterly edge of the low pressure bias making more progress into the West Pacific, going to like almost the date line. That's a bit of a reach. And the low pressure bias here starting to retrograde and all but gone as we get to the 1st of January. This to me clearly, if it materializes, And probably the decision point would be like November 1st right here. If you see the easterly edge of the low pressure bias actually moving further east, that would be a very good sign. This, we thought, oh yeah, that's all smoke and mirrors, but it actually did happen. We haven't gotten the strong westerly anomalies we were hoping for, but if it moves even further, that would be, at this point, I'll take anything. That, coupled with an active phase of the MJO, that could be the tipping point to start moving us into what I would call an atmosphere with more momentum. Right now, our atmosphere, we're still getting low pressure systems, we're getting storms, we're getting surf, but I think most everyone would say over the summer, yeah, there were waves, and it was kind of consistent, but it was never big. It was never particularly, meaningful from a pure southern hemi swell perspective. It was just surf, right? Something to do. And as we move into the fall, that's, I think, the pattern we're going to continue into until the MJO wakes up, and or probably driven by the low pressure bias moving further into the West Pacific, cutting out the legs of the high pressure bias. And now the whole global pattern needs to rearrange itself. We're already in some momentum towards La Nina in the Pacific, and we'll get there into November. But then if this happens, well, that'd be a great thing. But my guess is it would take 3 months before it's really going to start to significantly affect the global jet stream pattern. So if this happened November 1st, so you're into November, December, and January, so the beginning of February, then things maybe would start getting spicy. Maybe. Just for last, let's do, this is the strength of the MJO in standard deviations, 1, 2, 3. You can see how and this goes for a year, another year, and you can see that the MJO was like all red back in 19 and 2020 and had its moments in 2021. She got into 2022. Notice the red line is showing it more on the bottom of the scale here. 23, 24, and then here's 25. In April, we just like fell off a cliff, and we still haven't come back to date yet. The question is, what is driving that? It's not ENSO, it's not the MJO, because we also had the deepest ever PDO reading somewhere back in here too. And I think that's really the culprit on all this. All right, what's going on down in the ocean? Because that gives us a clue. Now we're into the El Nino, La Nina sort of indicator. Are we in La Nina? I mean, I think the answer is yes, some flavor of it. Okay, but we're looking at data here from subsurface temperatures from the ocean down to 300 meters, really down about 150 is what matters. Okay, East Pacific here, West Pacific here. This is TAO data. Again, these are the anchor lines on the buoys across the Equatorial Pacific. The X's are sensors on those anchor lines. You use a model to fill in the gaps, and you get a profile of what the water is doing. If you have more warm water in the west, as this chart suggests, that means trades are blowing stronger than normal, and that would be like a La Nina pattern. If you have a lot more warm water building up in the east, that would mean trades are weaker than normal or westerly anomalies, and that would be like an El Nino. Okay, today, the 29-degree isotherm, it actually has eased a little bit off to the east. It's at 175 east. I think it was at like 172 last week. The 28-degree isotherm was at 174 last week. It's at 172 this week. Again, this suggests that westerly anomalies, or at least a weakening of trades, has been in play. Now, the 24-degree isotherm, well, it was at 120. It's at 124 or 5 today. And so you can see most of the warm water in the west, cooler water in the east. It is not the actual temperatures that matter, though. It is the anomalies, difference from normal. The cool thing here is, well, yeah, not that warm temperatures out here, but they have creeped to the east a little bit. What is that? That is 155 west. They were back at 165 west a couple of weeks ago. And the cool anomalies here, that I think last week it was down to 4 degrees below normal. That's 4 degrees centigrade. Today, -2 degrees. So maybe a weakening, at least for the moment, of the cool pool. Here's the same chart, but amplified with satellite data. It clearly shows right here the leading edge of the warm pool subsurface at, it says like here, like 145, where last week I think it was at 160 or 155. So warm water pushing off. Now it still shows the cool pool, and it doesn't show it any weaker, but the movement of the warm pool to me suggests a weakening of trades. And then the sea height. All right, so this is South America. This would be Chile, Peru, Ecuador here, Central America. Equator there, date line there, New Guinea there. You can clearly see west of the date line. So this is surface heights higher than normal. Strip out the winds, the tides, the swell. And if the sphere of the ocean is higher than normal, it suggests warm water depth. Warm water expands. It'll create a bump on the ocean surface. Negative anomalies, so these are like -10, -15 centimeters. We're talking like that much. Negative anomalies suggest cold water depth. Cold water depth, of course, contracts, and you get a little divot on the ocean surface. So not a whole lot of a change, though. Up in here, there were deep negative anomalies, and down here all summer long they've modified. Yes, there's 15 centimeter anomalies here, but they just don't look as solid, as strong as they had months past. Upper ocean heat anomalies, the upper 300 meters of the ocean. Here we go. This is over time, going back a year. West Pacific here, East Pacific here. Here is last year's La Nina. Here's this year's weak La Nina-ish sort of pattern. But notice, at least for the moment, warm anomalies pushing to 150 west. The cool pool, smaller in coverage as compared to last year. And last year was a Modoki La Nina, so it was like barely a La Nina. This is even weaker. We're hoping that this will fade out in the coming months. We'll have to see. Sea surface temperature anomalies. The cold water down in the ocean eventually impacts somewhere in this area and gurgles up to the surface. And if you have stronger than normal trades, that upwelling process will create colder than normal temperatures on the equator. Colder than normal temperatures prevent evaporation, prevent lifting air. They support the development of high pressure on top of it. And this is like a classic La Nina kind of pattern here. Not super strong, but clearly is La Nina-ish in nature, extending from west of the date line the whole way into Ecuador. This is the sea surface temperature trend for the past 7 days. The bit of encouragement here, warming here, here, here. In fact, the only real cooling, it's just 5 degrees north of and south of the equator, is a little bit out in this region. And this has been happening for a couple days here. So indicative of maybe the inactive phase of the MJO at least weakening for a bit, and trade winds weakening in this area. Whether it's going to be long-lasting or not, that is the million-dollar question. Here's a different way of computing sea surface temperature anomaly differences. It uses the average global temperature and deviations from that instead of some absolute standard, but it's still painting the same picture. Cooler temperatures on the equator, suggestive of La Nina, but even maybe more so than the previous charts. The sea surface temperature trend in the Nino 1.2 region. This is on the equator right there off of Ecuador and the Galapagos. Temperatures today, 643 thousandths of a degree below normal. Between half a degree above and half a degree below is considered neutral. So for the past 1, 2, 3 weeks, basically hanging somewhere in a neutral pattern. We were weekly negative there for a month before that, and prior to that, pretty warm. But this is not the official El Nino monitoring region. This is sort of a heads up of what's to come. I guess I'll take that weekly optimistically. The Nino 3.4 region, the official El Nino monitoring region, on the equator from a point south of California out to about the date line. Current value, 832 thousandths of a degree below normal. Again, neutral is half degree below to half a degree above. Can ping around in there, and that's just considered a normal deal. So we've been below in La Nina territory since August 10th. Now, that's only, a month? Yeah, almost 2 months. It takes 5 consecutive months to officially be in La Nina, though I'm sure if they haven't already, they're going to declare that we're in some sort of La Nina, and pretty much everywhere you go, that's what people are saying. All right, so that we've looked at subsurface temperatures, we've looked at surface temperatures, but it's the interaction of the ocean surface temperatures and what's going on in the atmosphere, and the ocean can influence the atmosphere, but it takes a while to do it. The atmosphere is a big boat. It's not going to turn on a week or 2 or a month or even barely 3 months worth of data. Change in the ocean will affect the atmosphere unless it's a really dramatic change. So we look at the Southern Oscillation Index, the difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific, Darwin over the Indian Ocean. When pressure is lower in Tahiti in the Pacific, the index goes negative. Today's value, 9.41. We want to see a negative value. We go back a month here in this column. Well, we were at 17.47. You see bits and dribbles of negative readings, but nothing really biased one way or the other. So we do a 30-day average. Well, today's value, 0.84. That's pretty neutral. Where were we a month ago? 5.29. Okay, so it's going more neutral. But again, this is influenced by the MJO. Active phase of the MJO in the Pacific drives the index down. Inactive phase drives it up. So then we go to a 90-day average. Today's value, 3.72. I mean, that's really close to 0. Where were we a month ago? 3.46. So this suggests no real change. Let's see this data graphed out. Here we go. Latest 30-day values for October, plus 0.5 it says, but you can just look at the trend here. Now this says for the SOI, +7 to -7 is considered neutral. You can see how incredibly weak the MJO has been. Downward spikes are active phase, upward spikes are inactive phase. We haven't gone anywhere since like maybe mid-April or something like that. We've just been hanging right at neutral. So this suggests literally no momentum in the atmosphere. The MJO is doing nothing. The whole system is sound asleep. And then finally we go to the PDO, the Pacific Decadal Oscillation. This is again sort of a measure of, is there higher or lower pressure in the Pacific? The blues, higher pressure. The reds, lower pressure. This would be like El Ninos, and this would be like La Ninas. But you can, if you look at the data, you can see there's like these really long cycles that go on. And I'm not going to go back into the 1800s. I don't trust it. But starting, let's say, 1943, there was a long stretch here into about 1976. So 40 years of like a tendency towards La Nina. And then in 76 through about, 98, a long run of El Nino-like conditions. And then with the beginning in May of 98, roughly, July 98, the PDO went negative. You see how negative it went. We got as the lowest negative reading we've ever had in recent months. All right, so here is our most negative reading, -4.15. That was literally the most negative reading ever. But the good news is, well, it might have been a contribution of a bunch of local things, because now our index is at 2.38, which still isn't great. 2.38 is still about on average for where we've been for the past since 2021. So that's 1, 2, 3, 4, 5 years sort of thing. Are we moving in the right direction? Well, this update's only once a month, so who knows? But it seems like, at least for the moment, we are still in some flavor of the cold phase of the PDO, which tends to favor higher pressure in the Pacific and La Nina in the Pacific. And finally, sea surface temperature anomaly forecast from the CFS model for the Nino 3.4 region, the official El Nino monitoring region. Mid-October, here it is. The forecast suggests temperatures down to about 0.8 of a degree. I think that's about where we are. The official records, actually, if you go look at it, says we're only at 0.5, but I think we're colder than that. Temperatures going down, November would be right here to maybe 0.9, but then after that, By the time you get to January, well, half a degree below is neutral. By the time you get to January, you're even above neutral. So even, let's say, mid-December would be the end of this supposed La Nina event. So it'd be the month of October, November, and December. 3 months would be it, and we're all over. Then, of course, the model goes off into, well, it looks like El Nino territory, but I don't believe any of that. Now, this is the raw data. The PDF corrected version says temperatures going down to maybe only 0.8. and then rising from there, and still, again, above neutral by the time we get into mid to late December sort of thing. So the point being, 3 months here would just be enough to maybe start nudging the atmosphere more towards La Nina. But you saw the PDO data, and you see that this has been going on for years. So the atmosphere is already predisposed to being in a La Nina pattern in the Pacific. Would this change here be enough to break that pattern? No, definitely not. The MJO, though, might come to life, might help feed things along, might get us in a better setup as we move into the core of winter. For the immediate future, it looks like the West Pacific is where all the action is. No big surprise, the low pressure bias is there. We've been kind of saying it. That's what we thought the character of this winter was going to be, is storms in the West Pacific, the jet stream strong in the West Pacific, then ridging as it moved into the Gulf of Alaska with probably a high pressure blocking pattern over California, and most of the weather and everything moving into the Pacific Northwest with a low rain, low snow setup for California. Sure, we got a little bit of snow and a little bit of rain in the past week, and it almost would make one go, oh, wow, the pattern seems to be, an early pattern. Maybe this is a sign of what's to come. Well, we saw the models. We saw that it's just going to be pretty dry for the next 2 weeks. No real hope. So that was a false flag. Don't believe that we're off to the races here. But maybe if we get lucky, and maybe if the jet stream does better, and if the forecast is westerly anomalies building across the Pacific, especially as we get into later December sort of thing, that would maybe be a good sign. And I think maybe the start of the surf season, we've been saying this too, it's going to be offset by 6 weeks. I mean, we got a little swell here recently, and it was like, oh, well, maybe not. But no, I don't think the real start of the fall pattern would even start now till probably Halloween, or if not later, which is sort of like what happened last year. And then things will get moving in earnest. But I don't think the real bulk of our winter thing will be happening until maybe late January, early February sort of time frame, both from a surf perspective and a snow perspective. So we'll just have to wait and see on that. But for right now, the models, reality, everything that's happening sort of suggests a late start to the season, probably a dry winter, and not piles of surf. So when you do get surf, you better go make the best of it. All right, that's our video for this week. If you enjoyed it, give us a thumbs up. If you haven't subscribed, again, please subscribe. Click the icon down there on the lower right-hand corner of your screen. If you have a comment or question, write it up below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, it would be very much appreciated. You may hit the super thanks button down below, the heart with a $sign in it. With that, we are done for this week. We will do it again next week. Same time, same channel. Thanks so much for watching.